Okay, so sorry I couldn't be here today. But a lot of what we're doing today is all relates to yesterday. So as long as you understand the stuff that we were doing yesterday, today is just one step further. So we're still on the unit circle, that's B, right? Which means the radius is always 1, and we got our angle measure. So we're in standard position, and you got your picture over here, correct? And I'm on the unit circle. So my x value of my points would be here, this x value, and my y value. This is all the stuff we were doing yesterday, okay? But now we're going to relate it, right? Triangles, SOHCAHTOA, right? So, you know, we're SOHCAHTOA. And they're asking me about sine of this particular angle theta here, right in quadrant 1. Okay? So I know that, so, sine of theta would have to be the same as whatever the opposite side is of the angle over the hypotenuse. Okay? Well, in this particular example, on the unit circle then, sine of theta would be equal to the opposite side, which means it's y, the y value of your point, over the hypotenuse, which is 1. So therefore, sine of theta will always be equal to your y value when you are on the unit circle. We could do the same thing for cosine, right? So cosine of any angle is always equal to the adjacent side over the hypotenuse. In this case, on the unit circle, and theta being in quadrant 1 here, that means that it is equal to x over 1, adjacent over hypotenuse, which means the cosine of theta is always going to equal x when you are on the unit circle. So what does that do for us? That means that as long as you understood everything we did yesterday, which was just finding the coordinates on the unit circle, then basically you already found the sine and cosine values. You already did it, you just didn't realize you did it. So put the pieces here together, right? So this just says exactly what we just talked about. For an angle in standard position whose terminal ray, we should know what a terminal ray is, right? We did all that vocab at the beginning, standard position angle, starting the positive x-axis, passes through the point x comma y, and that point happens to be on the unit circle, then we know that the sine of that angle is going to be the y coordinate and the cosine is going to be x. Okay? Alright, so we want to find exact values of sine and cosine. Alright, well, if we understand what we're saying here, I want to know what the sine of 90 degrees is going to be. Okay? Well, then based off of what we just did, if I am on the unit circle, right? If I was on the unit circle and I wanted the coordinates of points, so let's say this point right here is on the unit circle. That means this radius is 1. If I were to actually draw the circle in, that would be my unit circle, and this radius is 1. Well, what is that last night's stuff? What does that make this point? 0, 1, right? That's the coordinates of the point at 90 degrees that's on the unit circle. And we just finished saying that means that the sine value, think alphabetical order. Cosine comes before sine in the alphabet, and x comes before y. So sine is the y value. So that means the sine of 90 degrees equals 1. And the cosine of 90 degrees then equals 0, because that's the x value at 90 degrees on the unit circle. Okay? So that just opened a lot of things up for you. Because up to this point with SOHCAHTOA, we couldn't do anything but acute angles. By putting the trig concepts onto the coordinate grid, we now can do angles, infinite number of angles, negative angles, positive angles, angles of 150 or whatever it is, which is what we're going to work on. Right now, all of these are our quadrantal angles, vocab, quadrantal angles, ones that are not in a quadrant. So I want to do the same thing. Sine of 180 degrees. Okay, well, what are the coordinates of on the unit circle at 180 degrees last night, right? All the stuff you did last night, and that would be -1, 0. So all the work you did last night, basically you're taking it one step further. We know that sine is going to be the y value. So the sine of 180 degrees, 0. The cosine of 180 degrees, -1. The x value at 180 degrees, the y value at 180 degrees. Same idea for 270, the sine of 270, so that's down here, coordinates would be 0, -1, sine is y. So that would be -1, the cosine of 270 would be 0. 360 gets me all the way back to the beginning, which was 1, 0. So the sine of 360, the y value is 0, and the cosine of 360, the x value is 1. So you don't need a calculator for that, right? We said our quiz is not going to be using a calculator for the first piece. You wouldn't need a calculator for, if I said what's the sine of 90, you should be able to figure that out. You should not need a calculator to do that. Find the numerical value for f of pi. So again, this is something that you should practice without a calculator. You do not need a calculator to do this. You are looking for the sine of 2 pi. So you do have to know, where's 2 pi? 2 pi is the same thing as 360 degrees. It is all the way around the circle. Okay, well, if I want sine of 2 pi, or f of pi, the sine of 2 pi then is the y value at 2 pi, which would be 0. So sine of 2 pi, 0. All right, well, how about the next one? Okay, so this one is the cos of pi over 2. Well, pi over 2 would be me splitting the top into 2 equal pieces. So that means 90 degrees. So pi over 2 is really the same as 90 degrees. Okay, so I'm really saying the cosine, so at 90 degrees over here, the x value is 0. So the cosine of pi over 2, 0. Then I want to double whatever the sine of 0 degrees is. Well, the sine of 0 degrees is the y value of 0 degrees. So that's 0 also, so 2 times 0, which would be 0 plus 0, which is 0. And down here, cos of 180. So I'm going to take -2 and multiply by the cosine of 180. Well, the cosine of 180 is the x value on the unit circle at 180. So that would be -1. And then I'm going to do 3 times the sine of 270. So 270, get myself to 270. Sine is y value on the unit circle. So 3 times -1. That would give me 2 minus 3. Final answer, -1. So you do not need a calculator for this. Your radian measures you need to be pretty good at. You got to be able to think through maybe or be familiar. Definitely try to get yourself familiar, especially with the 2 pi's, pi over 2, 3 pi over 2 is 270, that kind of thing. If I'm going too fast, you can pause and catch up and then keep going. Pardon me, you guys aren't answering my question. All right. Using the unit circle diagram, determine the exact value. So for many of these, typing them into your calculator is not going to give you that because some of them have radicals. Sometimes it works out okay, sometimes it doesn't, but again, you're not going to have a calculator for your entire quiz. So only for parts of it. So I want the sine of 30 degrees. Okay, draw a 30-degree angle. Here's my 30, all the stuff you did the other night. 30-degree angle. And if I want sine, I really just want to know the y value. Right, so here's my 30-degree angle. I want the y value on the unit circle. Okay, so here's my point. I'm going to put a 1 here so that I'm on the unit circle. And that means how much do I move to the right and how much do I move up would be the coordinates. But I only care, in this case, I don't even care about finding. You can write the whole coordinates, but all I care about is the y value. So I really only need this one. So you need to remember that, remember something to memorize. On the unit circle, opposite the 30 in a 30, 60, 90 is always 1/2. And that's the y value, and I'm going up. So sine of 30 degrees, 1/2. 45, same thing. So if you've got these memorized, this should be nice and easy for you. what do I have to realize? Okay, I'm at 45 degrees. There's my angle, 45 degrees. I want to be on the unit circle, so I'm going to say that's my point that I'm looking for the coordinates of, and this is a 1 because I'm on the unit circle. How much I move over and how much I move up tells me those coordinates. I only care about the y value here because it's sine on the unit circle. So, and it doesn't matter here because they're the same. Opposite of 45 is radical 2 over 2 when the hypotenuse is 1. So the sine of 45 degrees is radical 2 over 2. Cos of 60, same thing, but this time I'm looking for the x value on the unit circle at 60 degrees. So here's my 60-degree angle. Put my dot to represent my point on the unit circle, making that a 1. Drop down so I can see how much I would move over and how much I move up, but I am looking for this. I'm looking for how much I move to the right, which is opposite to 30, which I have memorized is 1/2. So the cosine of 60 degrees is 1/2. I can use the same picture for this one. Well, no, actually, never mind. I don't do that. So cosine 30, reference our angle is 30 degrees, put a dot for where my unit circle is, put a 1, figure out my coordinates. So I'm looking for cosine, so I really want this x value, which is really opposite to 60, which would be radical 3 over 2. So the cos of 30 degrees is radical 3 over 2. All right. So hopefully it's just one, you got stuff down from last night, it's one step further. Okay, gotta know the vocab to draw pictures of this stuff. The terminal ray of angle alpha, drawn in standard position, passes through this point. All right, well if you were plotting this point, you should be able to figure out what quadrant this is in. You are going left, and you are going up. If I am going left and up, I am in quadrant 2. So they don't have to tell you you're quadrant 2, you should be able to figure that out based on the information they're giving you. They also tell you you are on the unit circle. So you are drawing a picture of an angle that's in quadrant 2 based off of these coordinates. So some angle in quadrant 2, and let's say those are my coordinates right there, and the coordinates are negative 0.6, comma, positive 0.8. All right, well what do I know? It's a unit circle. So that distance is 1 from the origin to that point. And again, how do you plot this point? It's how much you move to the left, so negative 0.6, and how much you move up, so 0.8. Okay, so then what is my sine value? My sine value, this is my alpha. But this is my alpha reference, right? That would be the reference angle I would use. So opposite that alpha or the y coordinate on the unit circle is always your sine value. So the sine of this angle alpha is going to be 0.8. I also know this makes no sense because that would mean that the side of a right triangle is greater than the hypotenuse. And that can't be. That can't be 1.2 over here because the hypotenuse is only 1. This makes no sense because that would mean I'd be in quadrant 3 for my y value. And then we can just, 0.2 is not an x or a y value. All right, so if we understand what we're doing, we should be able to look at these, not necessarily tell what the actual answer is, but be able to tell whether our answer would be a positive or a negative. That's what we're looking for here. So think for a second. Again, it's about plotting points. That's all it is. It's about plotting points. And if I plot points in quadrant 1, that means I had to have moved right and up. So in other words, my values were positive to the right means positive, and up means positive. In other words, both of them were positive numbers if I'm in quadrant 1. If I'm in quadrant 2, that means I moved left and up. That means my x value was negative and my y value was positive. If I'm in quadrant 3, I move left and I move down to plot any points. So x is negative, y is negative. And if I go to the 4th quadrant, that means I move right and down, which means my x value is positive and my y value is negative. So put your pieces together. Your sign value in quadrant 1 then, which is your y value, will always be a positive answer. Your sign value in quadrant 2 will always be a positive value because your y values are always positive. In quadrant 3, your sign value will be negative, and your quadrant 4, your sign value will be negative because your y values are negative in quadrant 3 or quadrant 4. X values, cosine. Your x values are positive in quadrant 1. You're going left in quadrant 2, so they would be negative. You're going left in quadrant 3, so they'd be negative, but you're going back to the right in quadrant 4, so all cosine answers would be positive in quadrant 4. All right, so then apply this. We should be able to decide the quadrant where the angle is located, and then whether the trig functions will be positive or negative. And you can check it in your calculator later. So the sine of 57, well, 57 degrees is in quadrant 1. Okay, so that's the first thing I figure out. Where's the angle that I would graph? 57 is in quadrant 1. And now I say, okay, well in quadrant 1, both the x and the y values are positive. So even if I didn't remember that sine was the y value, I still know that this answer, the sine of 57, is going to be a positive answer. Okay, y value positive. 117, if I graph that, would be in quadrant 2. And cosine is the x value. So that means if I'm graphing anything in quadrant 2, any points in quadrant 2, it means I move left, which means the cosine of 117 is going to be negative. Negative 87. So negative 87, we have to realize we got to know our angles, all that stuff from day 1. If we can't graph our angles, if we can't figure out what quadrant we're in, now we're starting to get in trouble here. So negative 87 is quadrant 4. And so in quadrant 4, if I plot a point in quadrant 4, I move right and I move down. Sine is the y value. So I know the answer to the sine of negative 87 is going to be a negative number. It's going to be a negative number. So if I pulled up my calculator, it's done in degrees. The degrees here. And that was sine of negative 87. I'm not worried about what the actual answer is. I'm worried about whether it's positive or negative. So sine of negative 87 is a negative number. Okay, that's all we're figuring out, whether the number is going to be a positive or a negative number. So 105, quadrant 2. This would be drawn in quadrant 2. It's the y value, so if I'm in quadrant 2, the y value is positive. 257. That angle is in quadrant 3. Both x and y are negative, but sine is the y value, so negative would be my answer would be negative, quadrant 3. Okay, so this is just how good are we with radians. Do I have to convert this into degrees to know what it is? Or can I just think to myself, if I split up the top into 6 equal pieces, I only want one of those 6 pieces, the very first one. So pi over 6 would be an angle in quadrant 1. So maybe you have to go convert, you have to use that formula, just be very good at it, very quick. Okay? However, if you don't have a calculator, you're going to know how to do that. But 180 divided by 6, you can do that. So quadrant 1, and in quadrant 1, cosine is going to be positive. Negative, so really this is all the stuff. You're figuring out your angles and your quadrants is day 1. It's all day 1 stuff. And then all we're adding in is the y value or the x value. So sine of negative 2 pi over 3. So if I was negative 3 pi over 3, I would be at the quadrantal, the negative 180. But I'm only going 2 of them, so I know negative 2 pi over 3 is in quadrant 3. And your y value in quadrant 3 is negative. okay? 460 degrees, okay? So what do? We subtracted 360 to get an idea. It just means we went around once, and you got 100 degrees, okay? Well, 100 degrees is sitting in quadrant 2. So 460 is in quadrant 2 then. So 460 is in quadrant 2, and in quadrant 2, I'd be going left and up. This is the y value, so I know sign is positive. All right, I'm going to stop there because I think I've done enough of those. All right, so that's great. If you do this, you can figure, I mean, it's really good. Calculator, just type it in and look. But they don't always give you a calculator. They ask you things like this. So what are they saying to you? They're saying the cosine of some angle is greater than 0. In other words, it is positive. So you got to think to yourself, okay, let's think. Positive, positive in quadrant 1. Negative, positive in quadrant 2. Negative, negative, and positive, negative. Where is cosine, or your x value, positive? Well, it's positive in either quadrant 1 or quadrant 4. And if that's all they told me, I wouldn't know. I could draw an angle in quadrant 1, I could draw an angle in quadrant 4, and cosine would be positive. But they also say your sine value has to be negative. Well, where are your y values negative? They are negative in quadrant 3 and quadrant 4. So the only quadrant that meets both requirements is quadrant 4. If you have to show work, there's work to get shown for you. All right, this one's saying that your sine value has to be positive. Okay, so we're talking sine positive would be quadrant 1 or quadrant 2. Y values are positive. Cosine, they also want to be positive. So x values being positive is either 1 or 4. That means angle 1 is the only place that meets both requirements. So theta would have to be an angle 1, or quadrant 1. And for the other one, theta would have to be in quadrant 4, if you were to draw it. All right. Okay, using the unit circle diagram, write each of the following as an equivalent trig function with a positive acute angle and determine the following values. Okay, so listen, let's just figure out how to draw this first. And we're going to come up with our actual answer. And then I'll talk about what it means to do the other pieces. So your angle is 300. So when we draw our picture, we're drawing an angle in the 4th quadrant. 300 degree angle. And if I want sine, I want to be on the unit circle, put a little dot, I want the coordinates, this is a 1. I want the coordinates, and actually all I care about is the y coordinate, and I need my reference angle. So my reference angle would be, I've gone 300, to get to 360 would mean this would have to be 60. So my reference angle is 60. I know that if my hypotenuse is 1, this is part memorized, opposite to 60 is always radical 3 over 2. I am going down, so it's going to be negative. So the sine of 300 is negative radical 3 over 2. That's the sine of 300. Okay, the opposite over the hypotenuse. Now, it also says, using the unit circle, write each of the following an equivalent trig function with a positive acute angle and determine the following values. We found the value. What do they mean by write this sine of 300 as an equivalent trig function? What they mean is, you didn't, in your head, you didn't do the sine of 300, you did the sine of 60, right? That's what it's really all based off of. It's that reference angle that matters once you're out of quadrant 1. So the sine of 300 and the sine of 60 get me this radical 3 over 2. It gets me that number, that value. The only thing that I might have to adjust is technically 60 is in quadrant 1. So this value right here, the sine of 60, is going to be a positive number. But my original is a negative number. Okay, so this is a negative value, which means I got to adjust this one. So I'm not changing the 60 to a negative because then it won't be a positive acute angle. So based off the directions, this has to be a positive 60. Okay, so sine of 60 degrees, but I need the final answer to be negative instead of positive, so I put a little negative out in front. So these two things, take your calculator right now. If I type in the sine of 300, this is all you're doing. You're just showing what would be equivalent to it. So if I type in the sine of 300, and hit enter, and then I type in the negative sine of 60, it gets you the exact same. They're equivalent. They are the exact same thing written in a different format. The only reason I would need to do this is the directions told me to do it. There's no other reason to do this. So I'm only doing this because the direction said I had to write it as an equivalent trig function. That's the only reason I'm doing it. All right, let me try cos of 210. Okay, so what's the first thing I do? I'm going to figure out what the answer is. Then I'll write it equivalent. So 210 is in quadrant 3. Put a little dot for my unit circle, make it a 1. Drop so I can figure out what the coordinates are. Here's my 210. Very next thing I have to do, I got to find that reference angle because that's in here, right? And you find that reference angle. So that reference angle to here would be 180. I'm going a little bit farther, so 210 minus 180 tells me my reference angle is 30 degrees. Okay, so I'm in a 30, 60, 90 again. And I want the x value. So all I care about is the side opposite 60. If you want to figure out what both of these are, that's fine. I just have to remember you want the one opposite the 60 because you're looking for the x value, which is cosine. So opposite the 60 is radical 3 over 2. It's going left, so it's negative. So my answer is negative radical 3 over 2 for the cosine of 210. How would I write this as an equivalent trig function? Well, the cosine of 210 would always be equal to the cosine of that reference angle, which is exactly what I did to figure it out. This is cosine of 30 is always going to be positive because we're talking about an angle that's in quadrant 1. So I just need to figure out, do I need to adjust? The cosine of 210 should be a negative answer. So then I got to put a little negative in front of it. All right, I got room for this last one, so I'm going to do this last one. I'm skipping the sine of 240. Okay, so I draw my picture, negative 30 degrees, so I'm in quadrant 4. With my little dot, unit circle, figure out my coordinates. This angle is negative 30, which means it would be positive 30 reference angle. Remember, reference angles are acute and positive always, and they go to the x-axis. It's a 30, 60, 90. I'm looking for the x value. So opposite the 60 is radical 3 over 2, and that's a positive amount. So my answer, radical 3 over 2. So cosine of negative 30 degrees. Okay, what would be equivalent to this? So the cosine of negative 30 degrees would be equal to the cosine of my reference angle, the cosine of 30. Now, the cosine of negative 30 is a positive number, right? And the cosine of 30 is a positive number. Quadrant 1, quadrant 4, cosine are both positive, so I don't need to adjust anything. These are equal to each other. So I don't need to put a little negative in that case. All right, we've got a lot that we've been doing here today, but we've got one more piece to put together. So we're on the unit circle. Let's just, we're on the unit circle, right? Let's see, let me show this. So every time that we were sitting on the unit circle, let's say I'm here in quadrant 1, that's a 1. This is technically x and y, but it's also cosine of theta, comma, sine of theta, because cosine is your x value and sine is your y value, right? Or in other words, this, whatever the cosine of theta is that length, and this is the sine of theta on the unit circle only. So it's opposite, here's my theta, it's opposite over hypotenuse, it's adjacent over hypotenuse. Okay, so look at what they did. This is just, it's called the Pythagorean identity. If I know my sines and cosines, right, isn't this just A squared would be cosine squared, B squared would be sine squared, and C squared would be 1. That's where this comes from. It's really the same thing as A squared plus B squared equals C squared, except for C is 1 because you're on the unit circle. On unit circle. And you could just do it that way. However, they want you to use this Pythagorean identity. Okay, so instead of writing it as A squared plus B squared equals C squared, you'll see it as cosine squared theta plus sine squared theta equals 1. And that is really, because when you type it in, you got to understand, it's really the same thing as the cosine of theta, that amount squared, plus the sine of theta, that amount squared equals 1. This is the one that you got to keep in mind, because that's how you want to enter things. So what did they give me here then? They gave me the sine of alpha. Okay, so that's 3/5. So this amount is 3/5 squared, so equals 1. And they want me to find cosine. They want me to tell me what cosine theta is. I also know my alpha is terminating in the second quadrant, right? So like, if I drew a little picture, I know in general, somewhere in the second quadrant, if I'm sitting on the unit circle, right? Think of it like this. I know that it is something, comma, 3/5 or 3/5 going up. I know that just based off of this. This is my y value. So in my picture, I'm looking to find that. That's what I'm looking for. That's cosine theta, that x value. Okay, and I'm just using the Pythagorean identity to do that. So cosine theta squared plus, put that in my calculator, 9/25 equals 1. We did something like this the other day. So cosine theta squared equals 1 minus 9/25. So cosine theta squared equals 16/25, square root, and I have two answers. So cosine theta equals plus or minus square root of 16/25, or cosine theta equals plus or minus 4/5. Okay, however, so the coordinates could be, like we did the other day, could be 4/5, comma, 3/5, or it could be negative 4/5, comma, 3/5. However, we're in what? We're supposed to be in Q2. So both of these are not in Q2, right? This one is not in Q2. So that means I want to reject. So the cosine of theta then is going to really be negative 4/5. That's the one I want because in Q2. And the cosine of theta being positive 4/5 would be a reject in this case. So I don't actually have two answers only because the directions that I had to be at angle quadrant. This is the same exact thing. It's just that it's a little fancy route. So we're in the first quadrant. So we know we got an angle in quadrant 1. 1, drop it. Your x value is 1, the cosine theta is 1/3, so on the unit circle that's going to be 1/3, and they want me to find sine theta, which is really technically this. And they want you to use the Pythagorean identity to do it, which is really just the Pythagorean theorem. So cosine theta squared plus sine theta squared equals 1. Cosine is 1/3 squared, sine theta squared equals 1. This would be 1/9. Again, you can stop this if I'm going to. Subtract my 1/9, so sine theta squared equals 1 minus 1/9. Sine theta squared then, put that in my calculator, that would be 8/9. Square root, sine theta equals plus and minus square root of 8/9. I think we did one like this the other day too, when we were finding the point. So sine of theta is equal to positive radical 8/3. It's also equal to negative radical 8 over 3, square root of 9 is 3. This would reduce, well, actually, we're going to get now. Quadrant 1, right? So can y value be negative in quadrant 1? No, that makes no sense. Doesn't make any sense on my picture, reject it. And I'm just going to simplify this. Simplest radical form. So radical 8 is really radical 4 times 2, or radical 8 equals 2 radical 2. So the sine of theta in simplest radical form in quadrant 1 would be 2 radical 2 over 3. That would be my final answer. Because you won. All right. So hopefully you got all that. Go back and look at things if you need to. Be ready for Monday. And you have a quiz on Tuesday that includes calculator and calculator. All right. Have a nice weekend. See ya.